Okay, so the homework, this is going to go a little bit differently. For most of the time, I'm going to be using this blank space. I'm not going to have the questions. So if you don't have the handout in front of you, grab the handout. And if you don't have access to the handout, you need to do a screenshot or pause the video, or just understand that you're going to have to go back to the very beginning of the video to see this screen. Because in 5, 4, 3, 2, 1, we will not see it again probably for the rest of the assignment. I'm also basically just going to work these out because I'm running out of voice. I want to make the video nice and short, and I don't want to talk more than necessary. So let's do question A. For question A, you got to do a few things. One of them is find h of 1, which means finding f squared of 1 times g of 1, which is 2 squared, times, I think g of 2 is negative 1. So h of 1 is negative 4. The other thing we want to find is h of 5. And we know to use these two numbers because they are listed as the domain. It says on this domain, so we want to check the endpoints for that domain. Let's do f squared of 5 and g of 5. So that's also 2 squared, but this time it's times 4. So that total ends up being 16. So here's what we've shown. And once again, blue is just notes. We've shown that the graph of h begins down here, and it ends here at 5. And this is at 1. So to get from here to here, of course, we have to pass through a value of 1 on the y-axis. So here's what we would say in terms of work. We would give our numerical evidence, this is required, right? How much steps you show is up to you. But showing h of 1 equals negative 4, showing h of 5 equals 16 is required. And then we would say because h is continuous, the intermediate value theorem applies. If you took the practice exam, you've actually already seen a pair of questions similar to this. And if you haven't taken the practice exam, I imagine you will do better than your classmates because you had the benefit of this assignment. All right, so that is the very first one. We say the intermediate value theorem applies. And I'm going to clear the screen, so if there's anything you need to write, now's the time. For the second question, we have to show why a certain derivative happens. Why does h prime of c equal 5 at some point? So the first question was showing why a certain y value has to happen. Now we're going to show why a certain instantaneous rate of change has to happen. And once again, there's some work that you have to show. But for mean value theorem, for this question, you have to show that the AROC is a certain amount. So we're going to work out the AROC. These two numbers we actually just got from the last problem. They were 16 and negative 4, respectively. And so this works out to be 5. So we've shown that the average slope is 5. And so what that means is no matter what the function is, if that's the slope from endpoint to endpoint, then somewhere along the way, the IROC, right, the IROC or the tangent line is going to be parallel to the AROC. So what you would say is you would write this out, and then you would say because h is differentiable, right? Differentiability goes with derivative. Continuity goes with y value. Differentiable, the mean value theorem applies. And this is one of the rare things that you're allowed to abbreviate on the exam. You can say MVT, as long as you put it in the context of a nice explanation. Do not just put on the page as your only answer, MVT. Sorry, MVT. No amount of explanation points and smiley faces will make this a good answer. You need kind of all this stuff to go with it. All right, we're going to clear the screen, kind of do the next question. Is the function h increasing or decreasing at x equals 3? hopefully, you guys recognize that h increasing means h prime is positive. So let's just kind of check to see if h prime is positive. First thing we're going to do is take h of x and find its derivative. And this is going to require some product rule because of that product right there. But it's also going to require some chain rule to deal with that term. So let's do h prime of x. First, I tell you what, let's leave this alone first. Let's say f squared of x times g prime plus, and then now we're going to leave g alone, and it's this we need the derivative of. So the derivative of something squared is 2 something prime. So that's the derivative of this term, and then we still need our g of x. So is it increasing when, let's see here, what was the value? At 3, well, let's plug 3 in for all these values. Let's plug in 3 for all of the x's. And what it works out is, I believe, as long as I copied this right, 2 times 3 times 0 times 5 plus 3 squared times negative 1. And I'm actually reading off my answer key, and I should point out that this term, that's actually the f squared times g prime. This term is actually the 2f f prime of x g of x. But regardless, this is basically do the product rule, make sure this step gets the chain rule, and then once you plug in 3, it doesn't really matter how big of a mess this is. All of those values are somewhere on that table. We get a total for this, which I believe, let me just make sure is correct. This all adds up to 0. This is, or multiplies to 0. This is 9 times negative 1. Oh, it's negative 9. No. H is decreasing. And then if we wanted to kind of go the full Monty, we would say because h prime is negative. But honestly, if you've worked out h prime and gotten to a negative number, and then you say therefore h is increasing, it really is kind of implicit that you understand what this means. All right, pause for an announcement. Sorry, did I say increasing? H is decreasing on that last one because it was negative 9. H prime was negative. Shout outs to Meredith who corrected me. All right. Let's see here. I think the next one is kind of the big question where it says use the tangent line curve. This is going to take a lot of work. So we're going to do y equals mx plus b. But some of the work is saved for us. Because it says at 3, we already know h's rate of change at 3. We worked out in the last question. So it's kind of nice that we get to recycle that value. So all we need to use is an x value and a y value to find the b value. And remember, this is for the function h. So what we're going to use for our x is the moment. The moment is 3. And what we're going to use for our y value is whatever h of 3 is. And this I don't think we've worked out yet. So we're going to work it out kind of up here in the corner. It's whatever f squared of 3 times g of 3 is. If we look at the table, that ends up being 3 squared times 5. So it should be, well, whatever 3 squared times 5 is, should be 45. So let's work this out to solve for our b value. We're going to take 45. We're going to add this term to it. So we're going to add 27. And that should be our b. And b should be 72. Yep, 72. Hey, you're actually going to use this equation in tomorrow's homework. So do not ball up your homework and throw it away, or you'll have to redo this whole question. Because you're going to use the tangent line in Tuesday night's homework. So this was basically kind of a normal tangent line in the sense that our goal was to find a slope using derivative and then to use a ordered pair to find the b value. It just so happened the slope was an extension of the work we just did. So the next question is actually just another intermediate value theorem. We have to just say, okay, must L ever equal 100? And once again, we're given a domain from 1 to 5. So let's check the value at 1. Let's check the value at 5. And if 100 is between them, then gosh darn it, it's got to hit 100 at some point. So let's see, okay, what is h squared of 1? Well, we already worked out h of 1. H of 1 was... Sorry, let me check. Yep, it was 16, I remember. And so it's 256. So the function L starts off very high on a graph. Let's check L of 5, so that's going to be h squared of 5. And we already worked out h of 5, so all we need to do is square that value. Let's square 4. Oh, that's 16. So what we're basically saying, let me go to the blue, is this function starts off way up here at 256 and drops all the way down to 16. So gosh darn it, 100 has got to happen somewhere. So we say yes. Our reason is because L is continuous, the intermediate value theorem applies. And once again, you actually can write IVT on the exam. It's one of the very few times you can abbreviate. Do not write AROC on the exam. You have to write out average rate of change. But also you can't just write IVT and have that as your only answer. Even if you put an exclamation point there, it's still not enough. All right, I'm going to clear the screen, so pause it, and we're moving on. And we have a couple of questions left that I really like because they look scary, but what you really got to do is just stick to the basics, and it'll all work out. So we know that P is the integral from 1 to g of x, f of t dt. And what we're going to do here is apply the fundamental theorem of calculus part 1, which kind of says that if you take P's derivative, you get back to f. But this is one of those cases where instead of x, we actually have a function. So you got to substitute that function in for t, and then you have to chain on that function's derivative. And what this ends up looking like is basically the chain rule, because that's exactly what we're doing. We have a function inside a function. G of x is inside the integral function. So we have the integral from 0 to something. So you have f of something times something prime. I should take this 1 here and move it up closer to the integral so you don't think that it's a prime. All right. So now I'll tell you what. Drop my battery. Let's just plug, I think, 3 into this and see what we get. Now my battery's backwards. Now my battery doesn't work. And if this doesn't get fixed, I'm going to have to stop the video, which I hate doing. If you want to email me at this point and tell me that I'm a moron, that'd be fine, since you're already at your computer or your phone. All right, fixed. So let's find P prime of 3. Let's just plug the 3's in for the x's. I have this assignment saved as the leap of faith assignment. And the reason I call it that is just you got to have faith that it's all going to work out. Like once you do this step, don't worry about the final answer. Just replace x with 3 and see what happens next. Don't worry about every step put together. Just go one step at a time. And if you kind of do what you should know to do, it will all work out. Okay, so let's see here. F of g of 3. Well, g of 3 is 5, so that means f of 5. And then g prime of 3 is -1. f of 5 is 2, so this is 2 times negative 1. It's negative 2. All right. So the only, I mean, in this question it looks very complicated. The only thing that was actually tough was just remember that you plug the function in for t and don't forget to chain on the derivative of that function. If you do that, there's no other step that's actually going to mess you up as long as you have the guts to try. And that same thing applies to the last question, which is we're given q of x. So we're given this kind of crazy function that at first glance we might just want to like give up and go home. But if we have some guts to just try some stuff, it's going to be okay. All right, we have to find q of 5. So here's one thing that's easy. We know what 5 squared is, right? That step is not going to be hard. Now, what we really need to do is how do you deal with this? Well, this is the integral from 3 to 5 q prime. And I know I've got like these things that look like g's. They're really supposed to be q's. So I'm sure if you just cut the tail off, it's a q, right? All right, let's q it. Let's q it. Anyhow, anytime you see the integral and you're given values and you have a derivative here, it's almost always testing, like, do you know, like, the other side of this equation? That if q is what you're integrating, do you know that, or if q prime is what you're integrating, do you know that q is the appropriate letter for antiderivative? So really, we're just taking this whole thing and replacing it with the phrase q of 5 minus q of 3. Fudge. I just messed up this whole question. We're not starting over. I got thrown off. Some of you are probably going, Mr. Maltzby, that was a G prime, it was not a Q prime. Yeah, I know that. I know. Because it didn't make sense when I had a Q prime there. So this was 3 to x. This was a G prime of x. And this was a dx. So q of 5 means 5 squared plus the integral from 3 to 5 g prime of x dx. 5 squared is 25. I know that. But it's g prime that we're going to use g as its antiderivative. So we're going to use g of 5 minus g of 3. If you said q of 5 minus q of 3, that kind of puts you in a circle because find q of 5 is kind of the goal of the question. So using q of 5 made no sense. The struggle is real. All right. So plus, and then, okay, if this is g prime, then kind of the appropriate predicate or the appropriate other half of this mathematical sentence would be, well, what is g of 5 minus g of 3? And these are values that we can get off the table. It's 25 plus, and then we have 4 as our g of 5 value, minus, and then g of 3 was negative 1. So it should work out to a total of 30. I'm sorry, g of 3 is 5. Shout outs to Meredith. So this does not work out to this. It works out to 24. Sorry. I don't even know how to spell my own name anymore.